All right, here are a couple of examples that will show you how to solve or how to account for internal resistance of the battery. The first example, it's from your textbook, number 70 on page 442. So we have a simple circuit that has a battery and a resistor connected to it. And they give us the internal resistance of the battery and the internal resistance of the resistor. So I could write that this guy has 0.15 ohms of resistance, and this guy is 1.50 ohms of resistance. So the electrical current will go in this direction from positive to negative, right? And it will also flow through the battery itself. And since the battery and the resistor are in series, right, you will know that the current in series is the same. So this I total will be I through the battery, and it will be equal to I through the resistor. You know how we solve for the total I. We need to figure out the total resistance, which is 1.5 plus 0.15. So our total resistance will be 1.65 ohms. Now we know that the total current can be found as the maximum voltage, which is the EMF, divided by total resistance. So EMF is 12, total resistance is 165, so that gives us total current of 727 amps. Now since current goes through the battery and the battery has internal resistance, there will be a potential drop on the battery. Some energy will be used to move charges through the battery. So this potential drop will be the current, which is the total current, multiplied by the resistance. So this is our I total, and this is our resistance internal. So then if this is how much we lose inside the battery, 10.9 is going to be whatever is left over, because our total EMF was 12. So then we do 12 minus that will give us this. So if you were to connect a voltmeter like that and measure the potential difference across this resistor, it would read 10.9 volts. That is called the terminal voltage. The terminal voltage is the voltage that all the loads get in the circuit. Right, here's your homework problem. We have a certain number of resistors. Each one of them has a resistance of 15 ohms. They are connected in parallel. The internal resistance of the battery is 0.5 ohms. And they tell you that the terminal voltage is only half of the EMF. So here we go. Since these resistors are connected in parallel, and remember how we solve for parallel, it's 1 over R total equals 1 over R plus 1 over R plus 1 over R, and then we have to flip it for the total R. So this R parallel, in other words, that's the R total, which is 1 over R plus 1 over R plus la 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 la, all to the negative 1. And then since these guys are all R and there is an n amount of those, then we will have n over R to the negative 1, which flips it back here, and then we have R over n. So that's our total resistance. Now, resistance total, again, just like in the previous one, is the resistance of all the loads. Those are all our resistors, however many there are. This is our internal resistance of the battery. Now the current total is EMF over R total. Again, just like in the previous example. So then, this right here, this is the voltage used by battery, or That's the potential drop on the battery. So I can say that that is the potential drop on the battery. It equals total current through the whole thing times the internal resistance. Now the total current we said was EMF over R total, which is this. Oops. And again, this right here gets there. Now, they tell you that the resistance left over is half of EMF, which means that the resistance used by, the potential difference used by the battery is going to be half of the EMF, because the other half goes into the terminal voltage. So then I can say that, again, this is the potential difference, the potential drop on the battery right there. So it's EMF over 2. And then at the same time, that right here comes from this equation. And then we can cancel or divide by EMF, and we'll have 1/2 R internal over R internal plus R of all our resistors together. So that's the R of our load. So therefore, cross multiplying, I get 2 R internals equals R internal plus R parallel, which means that R internal, the internal resistance of the battery, equals the resistance of all those loads connected together. Then 0.50 equals 15 over N, and therefore N equals 30. So that's the long way with all the formulas and stuff. Here's the common sense. Since we have the resistors and the battery connected together, so think about this. We have total EMF will be delta V on the battery plus the terminal voltage. And they tell you that this is half, so that means that it's half, right? So then they're equal each other. Not equal EMF, but these two guys. This equals that, right? That will mean that these guys are equal as well. Because think, delta V, oops, let me continue that. So delta V on the battery will be I total times R internal, and it will equal I total times R of all our parallel resistors, right? That will give us, we can get rid of I here and I here, and that will give us R internal equals R parallel. Then 0.50 is our R internal, 15 is the resistance of 1 over N, and then equals 30. And that is it.